All right, so Jacoby asked about this question, 2012, number 5. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight at time t equals 0. When the baby bird is first weighed, it weighs 20 grams. So that's important information to know right there. And if b of t is the weight of the bird in grams at time t days after it's first weighed, then this is the differential equation. You should recognize this. This is a logistic differential equation. This is a maximum. Like, this is the maximum capacity. I think we did the example with like deer in my backyard. Your test was dogs in a kennel, where a dog got sick and then at so many days other people got sick. This is literally what the CDC and the WHO organization are using right now to declare this whole coronavirus thing a pandemic. This is it. So let b of t be a solution to the differential equation where your initial condition b of 0 equals 20. So A, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your reasoning. Well, is it gaining weight faster? That's a rate of change. A rate of change is a derivative. They gave you the derivative. You just literally have to plug in 40 and 70. So if I plug in, if I do dB dt at 40, at b equals 40, that's 1/5 100 minus 40, which is going to equal 12. 100 minus 40 is 60. 60 divided by 5 is 12. If dB over dt is b equals, it was 70, so that becomes 1/5 of 100 minus 70. 70 is minus 100 minus 70 is 30. A fifth of 30 is 6. Well, which one is it? The bird is gaining weight faster when it weighs 40. 12 is greater than 6, right? There you go. Quick 2-point answer. Answer with reason. Make sure it's a sentence. So you'll say the bird is gaining weight faster when it weighs 40 grams because dB dt, you could say dB dt at 40 is greater than the derivative at 70. That's how that's going to go. Part B, find the second derivative and use the second derivative to explain why the graph of B cannot resemble the following graph. Okay, so first of all, let's find the second derivative. So we're taking the derivative of that. So what happens is that becomes 1/5 1/5 is just a constant times the derivative of 100 minus b. Well, that's going to be negative the derivative of b. That's going to be dB over dt. Right? So then you're going to stick dB dt back in there. So you're going to get 1/5 times negative 1/5 100 minus b, which is really negative 1/25 times 100 minus b. And here's the deal. This is negative, right? So if I'm looking at this graph here, I guess you have to go back and think of what the second derivative tells us. Remember, second derivative tells us concavity, correct? So if I'm going to go from 0 to, I don't know what, like that is, the second derivative better be positive because the graph is concave up. Well, 100 minus all of that, less than 100 is going to be positive. A positive times negative 1/25 is going to be a negative. That makes it concave down, not concave up. So you have to say something like the graph of B must be concave down from the beginning, not concave up. That would be our explanation. All right, so Part 3, Part C, use separation of variables to find dB over dt. By the way, this is totally an AB problem. We did this last year. A particular solution to the differential equation with initial condition b of 0 equals 20. So first of all, let's see. Ooh, I didn't mean to do all that. We've got dB over dt equals 1/5 times 100 minus b. So separate the variables. So you get 1 point just for doing that correctly. So dB over 100 minus b equals 1/5 dt. Remember, second step, we integrate. That b is to the first power in the denominator, so it's really natural log, but it's a negative one. So you have negative natural log of the absolute value of 100 minus b equaling 1/5 t. And don't forget your plus c, right? So now you got to get b by itself. That's the thing. So first off, let's get rid of that negative. So you're going to have the natural log of 100 minus b equaling negative 1/5 t plus c. Get rid of the natural log. You're going to e both sides. And remember, to get rid of the absolute value, you have to have a plus or minus. So you're going to have we're going to say a equals plus or minus e to the c. We did this way back when. So then you'll have 100 minus b equaling a e to the negative 1/5 t. I'm going to go from there. Hold on a second. So 100 minus b equals a times e to the negative 1/5 t. Now you can use this to plug in your initial condition, where our initial condition, remember, was b of 0 equal 20. So plug that in. So 100 minus b is 20. 100 minus 20 is 80 equals a e to the 0. E to the 0 is just 1, so a equals 20. So you have 100 minus b equaling 80 e to the negative 1/5 t. So now get b by itself. So first thing you're going to do is subtract 100. So you have negative b equaling 80 e to the negative 1/5 t minus 100. Got to get rid of that negative. Divide by negative 1. You divide everything by negative 1, it just turns around. So b equals 100 minus 80 e to the negative 1/5 t. Jacoby, I hope that answers your question. All right. Keep working on the Cook Bible, guys. It's still due. Bye.